Hello guys, welcome back to my channel, and today we're gonna keep looking at math method, year 12, units 3 and 4, and chapter 9, differentiation. So welcome to the calculus. Okay, this is our term 2 priorities for calculus differentiation and anti-differentiation. Also, it's pretty important for you to know how to do it and understand it, because your final year exams are going to be tested these things a lot and combined with what we have learned through chapter 1 to chapter 7. Okay, let's look at what is derivative. So basically, the derivative just like means rate of change. Okay, just remember this one. Derivative just means rate of change. And if we specific, it just means instantaneously rate of change. So it means at some certain point, the rate of change. Okay. Before that, we talked a lot about gradient. So what do we mean by gradient or the straight line gradient? This gradient just means the average rate of change. For example, you're taking from home to the school. It just takes you maybe 10 minutes and the distance is about like 2 kilometers. So you use your distance divided by your time, you get the rate. Then this rate is your distance is change corresponding to the time change, right? So this is called rate, and we give the name in physics as speed or velocity to describe this rate of change. But again, we use total distance divided by total time. It just gave us the average rate of change, which means average speed. But for example, if you're waiting for the traffic light, or if you feel you are late, you just like running, then you feel tired, then you just slow down a little bit. So for each of second, to be honest, your speed might be different, right? So how do we find or how do we define that part of speed? I mean, like maybe t equal 10 seconds or like t equal 5 minutes. I don't know. So that's why we evolve with this. We call it derivative. Okay, that's the whole idea of to find the rate of change. Let's look at this one. First, I want to give you the geometric representative for derivatives. We got 2 points, which is P and Q, and they were just away from the curves. They were just located on that. So if we connect P and Q1, we got one straight line, then we got the gradient. Then I make Q1 slightly near the P, so become Q2. Then I connect PQ2 again, another gradient. Then I keep moving until the point that Q and P essentially are overlap, or essentially are just like closer to the P. They just become 1 point. So suddenly this line becomes like tangent line, which means it only have one intercept with our curve, right? So hence we just first focus on our attention to the gradient of the P at this tangent line. That's the whole idea. So basically it just means our taking fx plus, sorry, fx plus h minus fx and over the h. So in this case, my p coordinates is x and fx, and my q coordinate is x plus h and fx plus h. So I just minus this one. And to make h extremely small, then I kind of get this gradient. And if my limit, my h is just approach 0, I can get this derivative. And we call this one is first principle. This is our fundamental idea about the derivative and its definition. Okay, so once you saw this one, I need to go back a little bit to introduce what its limit means. Okay, limit just means if my h is inside the expression, then I just want my h just approach to some certain values to see what's this one going on. So essentially it just means you can directly plug the 0 in to get the answers. But before we're doing that, just make sure if for this type of problems, cancel or do the simplification if you can. Okay, once you've done this one, then you can plug 0 in. Otherwise, it's become 0, 0. You don't know what's going on over here. So let's go back to the derivative. Essentially, derivative just means taking the gradient of the tangent line, right? And this is just we call the first principle, and it is covered in year 11. So I'm not going to talk about that much. And this is for 9A, we just need to know the first principle. And for 9B, again, it's purely and fully covered in year 11. It's rules for differentiation for x to the power of n. Okay, this proof we don't need to really remember. We can directly remember the formula to help us to get all the calculations. But just need to make sure you guys know the constant terms or constant functions, the derivative just zero because there's no rate of change, there's no change for them. And for the sum, difference, and multiplication, if we're just doing some constant or doing for multiplication, if we're doing like constant, we can take the constant out, then doing the derivative. For sum and difference, we just need to do separately, then add them together. Okay, example 5 and 6, they both illustrate my points. And next one is, actually we're gonna recover this one in chapter 10, like the application, but it's worth to know, like gradient of tangent line, we can use derivative to find out. So hopefully you guys still remember other two things to find the gradient of the curve, sorry, gradient of straight line. First one, y2 minus y1 over x2 minus x1. So rise over run. And next one is gradient equal to tangent theta. And then the tangent line gradient equals dy over dx. So essentially, if question is asking us to find gradient of the tangent line, we have three methods to use. Okay, make sure you can connect them because this is pretty important and will be tested in the final exam. The next one I want to show is Leibniz notation. So it's another way to write derivative. Just make sure d over dx is one symbol and this y is just like the function contained with fx. Okay, if my z is x squared plus 2x, so my d dxz, same thing. Okay, 2x plus 2. So I just plug z in over here. Okay, make sure you guys notice the difference. And operator notation, the key things they emphasize over here. Okay. So again, for look at this guy, this says angle associated with the gradient of the curve at the point. As I mentioned, it's a linked angle with our gradient is tangent theta, right? So my dy over dx is equal to tangent theta, which is right over here, and equal tangent alpha. So that's how we link the angle with our gradient of the curve. Okay, just use this one. Just make sure this angle is defined as this straight line is associated with the positive x-axis. Just make sure that. So if my gradient, sorry, if my angle is like this one, the angle will be look like this. Okay, just make sure it's the angle between with positive x-axis. So again, for strictly increasing and strictly decreasing, we can use derivative to help you guys to know. So if my derivative is greater than 0, for all x intervals, the function is strictly decreasing. If it's less than 0, function will strictly decreasing. Okay, sorry, f dash x is greater than 0, my function will strictly increasing. And if my f dash x is less than 0, my whole function will strictly decreasing. Okay, to make sure you know that. And this part, again, will be emphasized in the chapter 10, which is application of derivatives. Okay, and this is for the 9b. And I'd like to go slightly more, a little bit for 9c, because this is the same thing. The n is just like a negative integer, but it won't influence our answers. For example, if my x is to the power of -1, so the derivative is -1 x -1 minus 1, so it's negative x minus 2. Basically just x to the power of n derivative is n times x to the power of n minus 1. So 9c and 9b are essentially the same thing, only they add a negative in front of it. Okay, you guys can quickly go through these examples to familiar with these ideas. Okay, for my next videos, we're gonna talk about something about graphs of derivative functions and introduce you guys more about other functions derivative. Hope my video is helpful, and if you like my videos, please subscribe and click the like button. And thanks for watching, and see you guys for the next videos. Bye bye guys.